Build network automation tools and share them with your entire network operations team safely and reliably. You can do this with Itential. Visit itential.com to find out more. That's itential.com. Welcome to Heavy Networking from the Packet Pushers. I'm Ethan Banks, co-hosting along with Drew Conway Murray. Follow us on LinkedIn, Blue Sky, and the Packet Pushers community Slack channel. Okay, let me set this podcast up for you. When someone from the executive suite of your company starts an AI initiative, what does that mean to you, the network engineer? The executive suite doesn't know what their AI idea might mean for infrastructure. They don't know what a neocloud is. They don't know the difference between AI training and inferencing. They might only have a vague idea of what they are even trying to accomplish with an AI initiative beyond telling their friends at the golf course that they have one. Well, that puts a large burden on you to know the engineering implications of what your corporate leaders are asking for. You need to be able to translate whatever product vision they've got into a network architecture that can deliver that vision. Our guest today is Phil Gervasi. Phil has researched AI technology thoroughly and can translate that research into practical networking knowledge. And after listening to our chat with Phil, you should have a head start on being able to translate an AI product idea into a network design that will support it. Phil, welcome back to Heavy Networking, and tell the nice folks listening who you are and what you do. I mean, you got a few different hats you wear. You're at Kentik. You've been there for a long time. There's a new company you were involved with called Solutional. Just introduce yourself for a minute.
Sure. Thanks, Ethan, and thank you, Drew, as well. And yeah, my name is Phil Gervasi, and I have been a traditional network engineer for a long time, maybe 15 years or so. That's a long time in my world. Also in architecture, so pre-sales engineering and working in enterprise, small and very large. And I became very interested in intent-based networking at some time, which pretty much just flowed right into machine learning and how we can apply ML to network operations and network data. And as one of the underpinnings of large language models and modern AI, ML led into a really close study and experimentation in my own basement POCs, and then eventually with customers and folks that didn't turn into customers, and we'll talk about that, why that is. But specifically looking at AI and its application to network operations, but very often IT operations more broadly. And it's amazing how sometimes it even spilled over into other industries as well. So for Kentik, I've had the unique opportunity to work with folks specifically in the application of AI and ML in network observability and just the application of advanced data analysis techniques and workflows to network data, which is very diverse and broad and divergent. So it's not as simple as do a summary of my flow logs, although that is useful, but going into some pretty interesting use cases. And at Solutional, which is something I do as well, I co-founded Solutional about a year ago with several friends of mine you may know, Scott Robon, one of the founders of the Network Automation Forum, and James Dirksen, a close friend. And what we're doing is really, we're helping folks in sort of a technical consultant capacity to understand what that means. Like you said in your intro, what is an AI initiative? What do I do with this? What are the questions I have to ask? And how do I work through this? From a high level perspective, from an operational perspective, and from a very deep technical perspective, how do I handle a streaming telemetry pipeline for real-time prompting, for example? We also do a lot of education. So that's something that I own for Solutional. So a lot of workshops, and soon, not quite yet, but soon we're going to have a video on demand training a la carte and as a subscription. So it's a lot of fun. But I want to say that, it's not all about AI. It is about the application of AI to what we do in networking. And that's really what I've been all about for the past few years, is really marrying these two worlds in such a way where it helps engineers. We dispel and clear out some of the hype as well, and identify what are those things that we can really do that can really help us. So it's been a lot of fun, a lot of very interesting, and for me, it's been an educational process. We're going to talk about POCs today, and I have plenty of never-ending POCs here in my basement on my servers.
You said basement POC earlier, and I was like,
Yeah.
that sounds like a math rock band that didn't quite make it. They opened for Dillinger Escape Plan that one time, and it just never worked for them. They never really connected with an audience, and yeah, they had the one album. So anyway,
It's way too technical music. That's why. Verse, chorus, verse is all you really need.
Okay, so Phil, you're deep in the world of AI. You've really embedded yourself in that. You've done tons of research and reading and
Hmm.
understanding its applicability to infrastructure, to networking, and so on. We've been talking about AI a long time before LLMs took over the world. So clarify for us what AI even means in 2025. It seems like in 2025, it's a large language model, so we can throw a plain English prompt at a computer and then get a plain English answer back. Are LLMs the only AI thing that we actually care about at this point?
No, it's not the only thing that we care about, and it's certainly not all of what AI is. Artificial intelligence is a very broad term that encompasses this entire this concept of a workflow that adds some sort of intelligence, that does some sort of programmatic activity with data. And so, part of artificial intelligence are the tools and the technical methods that we use, like machine learning, like data pipelines, like understanding workflows, understanding the difference between a model and an algorithm. Those are two different things. So, what does AI even mean in 2025? I think you're right to say that for a lot of folks, for the layperson, AI is ChatGPT. And for the advanced layperson, it's ChatGPT and Claude. So, it's a large language model, as we were kind of joking there. And that's not the case. If you look at AI as the overarching umbrella of the technologies that create that programmatic workflow for us, then and adding that human intelligence, quote unquote, to our data analysis, then machine learning fits under that category. Then, the components of data engineering that we're going to talk about today, machine learning pre-processing and data cleaning, all that all falls under that or a part of that category of AI. And so today we're going to touch on things like predictive analytics, a term that you don't hear very much, but we're still using all over the place. Models like logistic regression and various time series models and clustering models and k-means and all those kind of things to produce very valuable results, insights from looking at data. And in our case, we're talking about network data or maybe IT, data more broadly, but we're talking about network data. And how can I look at this and analyze it in such a way where I can get insights that are just, it takes too long for people to do, or maybe it's too difficult for human beings to do, unless you had like an entire team of post grads from MIT working on it for you, unlimited budget, unlimited time. And so using these tools does that more efficiently, faster, potentially with much more insight. And then as we talk about the incorporation of natural language processing and then doing NLP at scale, which is what LLMs really are, then adding that what I believe the intent piece that we've kind of been missing. Remember when we talked about intent-based networking for some time and then everybody
Yeah.
stopped talking about it and like, where did that go? Even SDN, it was like every blog, every podcast. And then it just sort of evaporated from,
Well,
the
it's
zeitgeist
not
of
like it
network.
went away. We just stopped talking about it as a thing. It just kind of got subsumed into
Yeah.
broader technology packages and
Well,
so on.
I wonder, Ethan, if we can liken it to the AI winters that we've seen over the years. Every generation or so in the world of AI since decades and decades ago, and we can trace the origins of artificial intelligence back to the 40s and the early computers right after World War II, even natural language processing as well, specifically. But every generation or so, there's an incredible amount of hype. This is not new. There's an incredible amount of hype, and folks in industry and in academia start to wonder, wait a minute, where are the results that we were promised? They're not there. And so we end up with what folks call an AI winter. There was one in the 70s, there's one in the early 90s, where funding dries up, where interest starts to wane, and you see fewer people go into those programs at university and things like that. Is that where we're headed right now? I don't think so necessarily, but it is something to consider that when folks think about AI, it's this thing that's new and the large language models, and it's really not. It's something that's been 80 years in the making. But what we have today, I believe, is a result of the incredible amount of resources, both hardware and cloud resources and GPUs, because everybody kind of gave up on crypto. Um, to do the computational activity in neural networks that we've never really been able to do before. And then also access to data. So if you think about it, if you're training AI models, whether it's a large language model or some other model, right? You need a lot of data to train the model. And that was hard to get to in 1987. It was proprietary, locked away behind closed doors in industry and in universities. But in 2002, you had like Hadoop and big data was on the scene, and that's what everybody talked about. So all of us, and the internet, let's not forget about that. So we had access for the first time to enormous amounts of data. So
You
this
had
isn't
lots
an
of movies you could pirate that were already pirated for you. You could throw into your training set.
yeah.
And so we've been using the word model a lot. Can
Mhm.
we just kind of drill in on what an AI model actually is, what that term
Yep.
means?
So a model is different than an algorithm in that an algorithm, and I know you asked what a model is, but I feel it's necessary to differentiate between the two.
Yeah, that's fine. Let's compare.
An algorithm is the procedure. It's the workflow that we use to perform some sort of to achieve some sort of outcome. So in pure theory, an algorithm doesn't necessarily have to be math, but in practice, it usually is a whole bunch of math, right? The model is the algorithm that's been trained on data. And so now we have a model that we can use and show it new data. It's been trained on data, right? The algorithm is the procedure. And so now we have this model that we have trained on data. And so we can show it, and therefore we're getting the results that we want. We know it's reliable. And so we can show it new data, trusting that it will give us some sort of a prediction, or maybe it'll identify the correlation. Because during the training process, it was successful over and over and over. So it's now reliable. And so an AI model is that it's an algorithm that has been trained on data, whether it's a predictive analytics model like linear regression or logistic regression, something like that, or a large language model. And so we are talking about the difference between structured and unstructured data here. And so after the model is trained, this set of procedures, usually encompassing math, and in large language models, we're talking about huge workflows with uh, um, neural networks that could be made up of many, many layers, which is where we get the term deep learning, all those hidden layers in a neural network. So they can be very large. But at each individual point in that model, in those nodes in the neural network, it could be relatively simple, discrete mathematical computations. So an AI model, an artificial intelligence model, is a trained algorithm that's been trained on data to produce reliable, consistent, predictable results. And that could be, again, something that's more akin to what we've been talking about in 2003. I keep talking about regression models, but plug in anything you want: k-means, dbScan, whatever kind of ML model you like, or like today, GPT or Claude or Mistral or Llama or whatever large language model you prefer.
So when we talk about models, we tend to talk about large language models, but I'm guessing you could have a model that's trained on, radiology scans to
Yes.
look for a tumor or something, or a model trained on network telemetry to look for, why did I have this brownout? Is that the idea?
That's exactly the idea. And that's where we're going to get into terms and concepts like computer vision, which you may have heard of. And so instead of looking at unstructured data in the form of text, you're looking at unstructured data. That means unlabeled data, data that has no real coordination to it. Um, you're going to look at, let's say, pixels, so images, or audio, so bits from music.
Waveforms.
Waveforms. Thank you. So it could be a computer vision model. Under the hood, it could have a lot of similarities with the large language model in that we're using neural networks. We're using the transformer model. Perhaps there's some form of attention mechanism, self-attention. Um, and, uh, and so ultimately, when we talk about these kinds of models, AI models, it's not just large language models. Now, I do understand that there's a special place for large language models today because it can empower, well, for what we do, engineers and other workflows outside of networking in particular, to do things that we really haven't been able to do today, or rather before. But what's interesting to me is that using a large language model, it sort of gives us easier access to other I call them mundane models, easier access to other mundane models that I might not necessarily know how to use. So I can speak naturally to a
Right.
workflow using NLP and engage with other algorithms and models and all this sort of thing to do some sort of task for me.
What I'm beginning to understand as we sort of shift over into the agentic AI world is that
Yeah.
what I'm understanding is you're essentially front ending an LLM so I can communicate with Model A that's really good at telemetry. Model B is really good at flow logs. Model C is really good at Wireshark.
Yeah.
And I've got an LLM front end essentially that lets me talk to those specialists.
Yeah, in theory, you're correct. You got the order a little bit incorrect, but you got the right theory.
Okay.
So you're going to speak to an agent that's going to then be able to identify which large language model do I use, or maybe it's just the single large language model that it's using, sort of as its brain in an agent system. So you're going to have hierarchical agents. You're going to have this initial agent where an end user is prompting and talking to, sort of, but it translates your English words or whatever language you speak. And because of how large language models work today, and everybody's familiar with using ChatGPT or Claude or Llama, they're great. They're very effective at understanding, generally speaking,
Intent.
your intent. And that's why, by the way, I referred to intent-based networking earlier, because I wonder if we're heading in this direction more than we ever have. But
Yeah.
so now the agent system can say, what is this guy asking me? Oh, okay, so I need to use that model, or I need to call this tool. Now, that does beg the question, though. And we're not there yet in this particular episode, but model evaluation. What happens if I swap Llama with Quen?
Well,
Do I get
yeah,
different
that's a
results?
question I had. Does it matter which model I'm using? I
Yeah, it
downloaded
does.
something so that I could run, I forget what the name of the app was, but it allowed me to pull a bunch of models down to my local desktop and work with them. And I'm like, what? Does it matter which model I'm using?
Yeah, it absolutely does. You probably downloaded a Llama, I'm guessing.
That was one of them there, but I
That was
had
one of them. Okay.
dozens of choices. Yeah.
Yeah, Olama is the framework, the application, and then you can download a bunch of models and run them locally. And whether it's local or not, if you swap one model for another, the danger, if you want to call it a danger, is that you're going to get different results. And if you've ever put the same prompt into ChatGPT or Claude twice, 2 times in a row, you'll notice that you'll get a slightly different response. Well, can we do that with hard metrics here in network operations? The answer is no. Well, we can put guardrails. It doesn't mean we can't use it and then throw everything out. There are mechanisms and workflows to mitigate any kind of problems there, but it does still mean that there is a problem, and just swapping models isn't always as easy as it sounds. Now, there are certain models that are going to be more effective in one area than another. And what's interesting, Drew, you mentioned agent systems and agentic AI, and then being able to call on specific models and tools that are sort of specialists in an area. It's interesting because it reminds me of, not that I was around I was around in the 80s, but I wasn't like building networks in the 80s. It reminds me of the idea of the expert system, where you have domain knowledge that's explicitly programmed into a system, whether it's just rules based or a little bit more complex than that, and it's just law, or it's just medical, or it's just technology, and it's an expert system. It's like, wait a minute, it's 2025 going into 2026. Are we just sort of like doing expert systems again? Well, sort of, yes, and that's okay, because we're doing, like you said, Ethan, we're doing a front end with a large language model that allows us to determine intent, that allows us to do this more programmatically. So it's really, really interesting. But the things that we can do today already, before we get into the future stuff. I mean, everybody says that 2025 is the year of AI agents, right? And I know that people are working on it, and there's some progressive organizations that are, but I talk to enterprises all the time, and they're often asking me for help. And I will say, I'm going to get in trouble for this. 97% of organizations are not using AI agents yet. So yes, I'm sure there are those exceptions, and those are the ones that people are going to call out. But folks are still exploring this, and how do I do this? But what we have been doing for years, Ethan and Drew, is forecasting traffic spikes, doing anomaly detection, whether it's for traffic analysis or for security purposes. We've been applying models to understand how we can optimize our networks with load balancing. And
Or like fraud detection with credit card
fraud
companies.
detection for credit card companies, but I was staying within the realm of network operations, but you're right, Drew. So we've been using large language models, or at least natural language processing, for years for sentiment analysis and for things like that. And now, as we get into agentic systems, it's not new in the sense that we can do other things. It's that we're going to be able to chain tools and actions and then front end it with intent, so that we don't need to just have 200 developers creating our playbooks for us.
I like that you started on intent, and you're going to bring us back around to intent, in 5 years, but that's a different discussion. So one thing I hear all the time in discussions around AI are training and inferencing. And could you kind of help us understand the differences between those two and what they're for?
Okay. Regardless of the model, whether it's large language or a predictive analytics model, training, think of it like building the brain that you're going to use. You're building the brain. And then
You're
inferencing is
building the
when,
model, or you're putting data into the model?
well, it's both. You're building the model in the sense that you're feeding your workflow that you created, your algorithm, right? That you're starting off with educated guess with a lot of data. And then you ask it a question or a prompt, and because it's the training phase, you know what the answer should be. You're testing the model and you're saying, all right, let's see what's going on, Mr. Model. And the model produces the result in this training phase. And the result, you can measure its difference with the expected result. And we're using gradient descent and loss functions to do that. And then in a process, for large language models in particular, in a process called backpropagation, we go back and we adjust certain parameters within the model, and hyperparameters as well, to uh, make the loss function less, to reduce it, and to
Mhm.
make the result more accurate. And we do that iteratively over and over and over until we are satisfied with the result of the model. That's the training process. And
Okay,
that's what I mean by
so
building
let
the
me
brain, Ethan.
Okay. So reading that back to you, there was a demonstration I saw where someone was using AI and training a model. I think that's fair to say, to drive a car through a maze. And if you hit the wall, you were out. And so as he did a fast forward on the iteration, as the model trained, the car made it progressively deeper and deeper until the maze, until it was able to successfully navigate that maze and make it through. So is this
Yeah.
what we're talking about with, like, there's errors early on, we're not getting the result we expect, but eventually with enough training we get there?
Yeah, except that you're talking about reinforcement learning, which we
Oh,
do
okay.
use with large language models. We use reinforcement learning with human feedback, or RLHF, and that's when you have like the little thumbs up, thumbs down, or Claude or ChatGPT gives you two responses, and they say, which one do you like better? And they're basically gauging from your feedback, what is the better response. But that is part of training, absolutely. Now, what I was speaking about is not necessarily reinforcement learning, because we're talking about a
Okay.
huge amount of unstructured data with large language models, text. So through the process of tokenization and creating embeddings and all of that, we dump everything to a vector database and we start measuring semantic similarity.
You're using words that are abstract if we're not steeped in the knowledge.
Mm,
So make it
yeah,
practical. Is it like there's some
yeah.
human looking there and I put in an English prompt and get an answer back and it makes sense to me, or it doesn't, and I kind of grade the model on the answer I got back?
Yeah. And thank you for that, because that's exactly, my brain is living in that world, so I immediately go down into the weeds. So that's good. But it's pretty much like that, where you put your prompt into the model, and it spits out some answer that's ridiculous or that's just incorrect or something along those lines, so that this model's not really ready for service.
Right.
Now, when is it ready for service? That's up to the model developers and all the creators there. But that's exactly right. And so that's why it takes weeks or months before you get a new version of whatever model. And that's why these data centers are so big and then running on an incredible amount of power and so many GPUs, because it's constantly running these training jobs over and over and over until you get what you want. That's what builds the brain. Once you're set, the model is closed. Imagine like compiling your code, right? The model is closed. And you could also call this pre-training, by the way. And so it's important to make this distinction, because, I hear folks, sometimes vendors, sometimes people saying, I just trained a model to do this. And I'm like, you probably didn't. I mean, you probably did something else, like you built a RAG system, which we'll talk about, or, you did a little fine tuning because you have a local model you were able to do, or large language models are generally memoryless, so you have to augment them with some sort of memory, so it understands, like, over time your chats, and it can refer back to other chats. So maybe that's the training that you did, but you're not going back and adjusting parameters necessarily. Now you can, like, you can do that with a local model with open weights, and go back and do that. And there's some really interesting ways to do that if you really wanted to. There's ways that you can do that with fewer resources, like using low rank adaptation, LoRa, where it doesn't cost you, hundreds of millions of dollars in a giant data center. But that's the training part, building the brain that is now reliable and giving you the answers that you want. So now that you have it, you can use it. And that's what the inferencing is, right? Inferencing is when that's what happens when you send a prompt to ChatGPT and then you get an answer back. It's going to
Yeah.
compute your response. It's going to take your response for large language models, your query or your prompt, It's going to tokenize it, throw it into a vector database, and look for semantic similarity, like I said. So what is this person talking about, using all these mathematical computations, and then predict what the answer is going to be. That's important. Training, inferencing, all of this stuff is based on probability. What is the most likely next word I should give this end user, or this next sentence?
Yeah.
So these models, large language models in particular, make it clear, that's what we're talking about here, are probabilistic. And that's why switch one model for another, you might get a slightly different answer. They're not deterministic.
So is inferencing then just a function of the model operating and interacting with users, or is inferencing like an additional phase where this model can continue to learn and maybe make new relations that it didn't know before?
Generally speaking, the inferencing is just running a trained model. Again, like consider it compiled code where you're not adjusting the parameters anymore. So it's not learning through that process of backpropagation. Backpropagation is like the learning in machine learning. So it's just taking your new inputs, your prompt. Maybe it's your telemetry. It doesn't have to be an end user. It could be machine to machine, via API, which is very common today, to generate your output. So it's faster than training. It doesn't take months. It can happen very, very quickly, in milliseconds even. It's much, much cheaper. So you're not talking about I need $100 billion to train this model. No. But I will say, Drew, that it's still very resource intensive, especially at scale.
It is story time with Ethan, courtesy of today's sponsor, Itential. For several years in the pre-automation days, I was on an engineering and architecture team that would help develop standardized code stanzas for new features that we would bake into our managed router offering. Now, once that configuration code was fully tested, we would move into deploying the code to client routers. By hand, often with a network operating system code upgrade required first. And as you can imagine, every so often something would go sideways in the process. The ops tech would fat finger something, a paste buffer would fail over the WAN because reasons. Something, usually a human something, would go wrong. My point is this, back at that time, there was no way to craft an automated process that would make sure the config went in exactly right every time and then share that process with the ops team. They would just punch the change into the CLI like a savage, and often they weren't even knowledgeable enough to react correctly when something went wrong. Time has thankfully moved on. Now we have infrastructure as code, and we've got developer tools and programmatic logic that we can use to code a mature playbook or a script that's got input checking and error handling and testing. And what's more, we can share these tools with our ops team without them having to understand a thing about the tool's inner workings or even have an environment to run the tool in. Now, how does all of this happen? With Itential. Itential can create an automation execution environment everyone in networking can use safely and reliably. To find out more about Itential's products and how they help you build an automation platform, visit itential.com. You can test drive Itential free for 30 days. That's itential.com. So let's take these concepts. We're 25 minutes in, Phil. So let's take these concepts of AI, large language models, what a model is, the notion of training a model, and then using that trained model via inferencing, and then map that to what I think some people in the audience might be facing. Their CTO just said, hey, we need to make AI a thing. Okay, so with that directive, how do you approach the AI initiative problem? Is there a framework to tackle this thing, a set of tasks we should be walking through to define what it is we're actually trying to accomplish as a company? How do you go after this thing as an IT person?
Yeah. First of all, I love that question though. If the CTO comes to you and says, we need to do AI in 2026, and you're stuck, that means I have new business. That's a prospect for me. Because this is a conversation.
Okay. So the answer is call Phil. Got it. Okay.
Phil has entered the chat.
Pocket, guys. But the reality is that a lot of folks don't know where to start. What do I ask? What do I do? And there's a lot going on there. And walking through that process has been a big part of my life over the past year and a half. With lots of folks. Some of them don't turn into customers because the answer is you don't need to be doing this. You're barking up the wrong tree. But to answer your question a little bit more explicitly, I think that the mistake that a lot of companies make is chasing technology instead of outcomes. So when you get that kind of directive from a CTO or a CIO, the first question you need to ask is, really, do we need to be doing AI? Now, we'll unpack how you answer that question. But I do believe that that's a mistake that a lot of folks make. They're chasing the technology for whatever reason. Maybe the board wants it, and therefore you're kind of under the you're under the pressure to do that.
Of course, we're doing crypto. Of course, we're doing blockchain, etc. Yeah.
Yeah, but you got to start with those top level fundamental questions that you ask in any technical project. What problem are we solving? What data do we have? What data do we need? Who owns that data? And if we do all of this stuff, is that going to create any business value? So how do I map a technical KPI, how fast a model can run through data and give me an answer, to business KPIs? Does it matter if it's fast or not? So there's all sorts of things. But the first thing is that you need to avoid solution chasing. And so if you hear the directive, we need to use LLMs coming from on high, for me, that there's a check in my spirit saying, okay, well, why? Like, what is that going to solve? What is that going to do for us? And sometimes the answer is really awesome and we need to chase it and build a POC. So if you want to start with a framework, you ask for a framework. And as engineers and former engineers, I'm with you. I want steps and procedures. But you do need to identify your business objectives. So what is your business objective? In networking, it might be to reduce your MTTR. You want to optimize your spend, like on cost per port in your data center, things like that. Maybe you want to improve customer experience. How do we do traffic engineering more intelligently, so that way applications are delivered faster, lower latency, whatever it happens to be. And so now that you know what you want to do, you could start to identify, what kind of data would help us answer those questions? You see, you start with that. Now you could say, all right, well, I need flow data. Oh, I need all my configuration files for all my devices because it's a security initiative, right? So maybe I want to do that. Or it's more of, how do I make my users happier? Well, let's do a sentiment analysis across all of our tickets in our ticketing system. That's not flow records. Maybe it's streaming telemetry and SNMP or syslog event, whatever.
When you say sentiment analysis, I think of a human. So is it like you're talking? Are we talking about the interaction of people, the user community with IT, that kind of thing, or something else?
Yeah. It's basically you got a bunch of tickets written in a language, let's say English, and you have your NOC engineer putting stuff in there, and so you're able to understand what's the nature of all of these tickets in English. What's the language that's being used? Customer A was really upset because this, or slow. You start picking up words like that: slow, fast, outage, all those kind of things. And that could also be not just tickets, but it could be TAC calls, right? So maybe you have a technical assistance center, and so you have transcripts, and so you can look at the language. We're not looking at hard metrics here, and you can use artificial intelligence to understand tone and create those summaries with some sort of insight. Now, could you do that on your own, Drew? Yeah, you could go and read all that stuff. And I know that you edit a lot of documents, and you do a lot of that. But imagine being able to do that at scale very, very fast. And then
does our network make you happy? Let's ask AI.
Yeah. And you say that like tongue in cheek, but yeah, that's a great question. But then what does happy mean? So that's why large language models can be very useful. So, you start looking at that inventory of data. In this case, we just went into the unstructured realm with tickets and transcripts and all that kind of stuff, but it could be very hard metrics. Well, it should be if you're doing network operations. But then you got to define your use cases. All right, now we know we have this data, and who owns that data? What are the security regulatory bodies that govern that data? And who has the credentials for this? And all that stuff has to get ironed out. But now let's map these use cases to business value. Well, who cares if we reduce MTTR? Or who cares if we do a little better traffic engineering? What does better traffic engineering even mean? Well, if we now start to map it to it reduces this amount of dollar amount spend per month, that's when you start to get what is it called? Not the approval, but like you get backed by your C-level and they start giving you funding to run your project. Yeah. And another part of that, once you get to that level, you got to make a decision from an architectural perspective. Architecture is strategy. The AI components, the ML algorithms and models you use, those are tactics. So start with the strategy. We're not even there yet. We haven't decided which ML model we're going to use. But you do need to now decide if you're going to build this thing out yourself, you're going to buy it. It's going to be some sort of a combination of the two, where maybe you don't build the model, but you build the workflow. So there are decisions that are very, very important to make here in this early process, in this framework. And then, of course, you have to plan for things like governance and regulatory bodies, like I said. But ultimately, if you can't articulate ROI, you're just experimenting. It's going to be a POC in your lab or in production, which is not so good, but it's just going to be a POC that goes on forever and then fails. And before we started recording, we discussed how there was an article from MIT just recently, a study that said that 95% of AI POCs just fail, and I think that was from last year. And there's more nuance to that. Like, why did they fail? Was it had nothing to do with the AI? Probably, maybe had other reasons involved. But nevertheless, the spirit of what's going on there is that people are jumping in technology first and not with this framework first. And so they're solution chasing or technology chasing. And sure, the POC is just gonna go on and on because nobody knows what the value is. Well, how do I know if this POC was successful? And then it just fizzles
So
out.
what I'm hearing you
Very
say
common.
is that just because it's AI, it's not like there's a brand new way of thinking about this. If the C-level suite is coming to you saying we need an AI initiative, you would go through this the same way they would say, we need to go to cloud. It's
Yep.
the same questions tied to business value. What are our objectives? What are our outcomes? How do we measure them? What data do we need? And so on. So it's not like a whole new ball of wax. It's just a new technology, and you got to ask the same questions.
Yeah, there are going to be different questions, of course, because you're
Sure,
going to get
sure.
much more heavily into data engineering and things like that, and
Yeah.
and data pipelines, and you're going to need different types of staff. Very, very common. Well, I was going to say it's very uncommon to have data engineers and data scientists on a network operations team. And
So can you talk about what it is about the data that maybe is going to be something new or a snag for folks who haven't gone through an AI initiative before?
Yeah. So, the data is the lifeblood of any AI initiative, whether it's traditional predictive analytics or, using large language models to do something interesting today. And we'll talk about some use cases, but the data is what we're investigating. That's what we need. So whether you're trying to predict something, well, you need the historical information in order to predict future state. So you need those, packet drops and latency measurements. And with things like sentiment analysis or with summarizing your configurations or identifying, is there a pattern in my data that looks like a threat feed that I received from Cisco this morning, something like that, right? All of that requires a significant amount of data to understand what's going on with your network. But not only that, that's the inferencing part. You need the data in the first place to train those models. Now, that part I don't think is as relevant, because I don't think by and large most people are going to be training models from scratch.
Yeah.
They're going to be using models as a service for the most part. That's not true for everybody. And that might even be if you're using a local model where you download a Llama or a Mistral and then you fine tune it and adjust it for your own purposes. So the data is I've seen this quote many times, and then in talking with customers a bunch of times about this very problem. It's not a problem, it's something that you just have to consider. The data engineering, the thinking through and building and then operating the data pipeline can be like 75%, 80% of any AI project. Because remember, once the thing is in production, well, you have to keep tweaking it. You have new data to add. You have new sources. You have sites that you spin up and spin down. You have latency problems with one database talking to another with something like that. Maybe you don't use streaming telemetry and now you do, and you want to get results even quicker. Well, how do you handle that in your ETL, in your data pipeline? Do I use Kafka? Do I use this? So there's so much data engineering that happens before you get to the cool part, which is the data science part, which is the part where you start like doing cool things with applying a model. And that's a lot of the, what leads into build versus buy. Like, can I do that? Do I know how to do that? Do I have the money to do that?
You talk about companies that are chasing technology and they're doing AI because it's cool, as opposed to they have a specific problem that only AI can solve. Okay, so in the different different customers, clients that you've talked to, what are the AI use cases that you're seeing? Like, yeah, that's legit. You should be going down the AI road, whether that's tied to network operations or whether it's just some general business initiative.
Yeah. Yep. That's a great question, because sometimes the answer is you don't need AI to solve this. You just need a Chrome runbook, or you could do this in Excel, like for a nickel, in one afternoon. You don't need to do this. And there's a great quote by Kavita Ganesan. I apologize if I pronounced her name wrong in a book I read over the summer. Actually, it was last summer, 2024. And she says, AI is too expensive to be used on problems that are too small, ones that could have been solved with better software engineering or even manually. If you've been talked into using AI and you're yet to see a clear benefit, that's a sign that you've been overpromised. And I love that quote. And I literally copied and pasted it, and I have it on one of my screens here. And it's a conversation I have. So it's not a trivial endeavor to build out a data pipeline. It's not a trivial endeavor to go hire data scientists and data engineers and to do all of this. And so the use cases have to warrant the cost, both in time, effort, money, grief. And so when you start to explore this, it's like opening up Pandora's box, right? So Pandora, you remember the Greek mythology of Pandora's box. She opens up this box to let all the evil out into the world. And then she closes it really quick, and there's still hope inside. So I am not, I'd be remiss if I said that um, going down this road is just going to be pain and heartache and evil. No, there is hope. There is great opportunity as well, but we need to be strategic about how we approach it. And so, again, whether it's the build versus buy argument, which is it's a discussion that we've been having for years, both in software development and in cloud and public cloud and things like that, and in SaaS providers, and then also in data engineering. So you can start building certain components where you perhaps build your workflow, but certain aspects of those components, like the data pipeline, you can outsource that part. So there's some interesting things that are happening now in the world of AI for network and IT operations, where it's not an all or nothing kind of a thing. Drew, did I answer your question? I feel like I went off on a tangent.
Well, I think wanting to get a better sense of, so my assumption is people might be thinking, okay, I've got, a whole bunch of servers filled with a whole bunch of logs. Can I just chuck that into a model and hey, presto, interesting answers are coming out? Or why do I need a data scientist?
Well, you know what? The answer to your question is yes, you can do that. With the context window sizes that we're seeing now, you have 1 million tokens that you can stick into a prompt. You can just dump all your logs in there, copy and paste. That is actual a use case. That's an actual use case. Why not, right? We're using, Cursor or Claude Code to generate some Python for us. We dump our logs into the thing and we say, hey, is there anything with these flow logs that speaks to whatever? And you can do that. Now, the more you do that at scale, the more difficult it becomes, because there are problems where you start to see hallucinations because you just dumped literally 1 million tokens into the prompt. But that's also more transactional to me, Drew, where you're using that as a knock engineer, as one of your tools on your desktop. Now, and so these are legitimate use cases. It's a way to augment an engineer to create code, to look at some logs and do a quick summary, to summarize tickets, whatever it happens to be. And because a lot of these models have been trained on the public internet, they've been trained on Cisco docs and Juniper docs, so they can help you with some architecture and things like that. But as we get into more advanced workflows now, where we mentioned it earlier on, where you're talking about agents and then agents using a large language model to understand intent, and then therefore autonomously create the workflow for you in an agentic system, you can do much more sophisticated things. So perhaps it understands that, what you're trying to do is a prediction. Let me apply this ML model to this particular data set, and then boom, you have a result. And so you're using natural language in this agent system to really, in effect, do some of that basic stuff that we've been doing anyway, but at a greater scale. And then if you start looking 2 or 3 years down the road, yes, I said 3 years down the road. Some people would have you believe that we're doing this now, but 3 years down the road where everything is self-healing and autonomous, and you have a level 1, level 2 engineer sitting next to you in AI form, I don't know folks that are doing that just yet. And there was a quote from Defense Scoop from the CIO of the Army. He says, our biggest lesson learned, this is with regard to AI, is that this is expensive stuff to do. And I think that's really driving our peeling back and tightening the guardrails on use cases. So to answer your question, Drew, yeah, you could do those simple things. But what we're seeing is, are there use cases if we make these into very advanced workflows where they can augment engineers? And that's where we're headed. We're just not quite there yet.
Okay, but so I should be thinking about the data, the state my data is in, how much data
Yes.
I have, does it need to be cleaned, analyzed? Do I need a data scientist to help me figure out the best way to leverage all of this data that I'm trying to, okay.
Or you hire, you have a vendor, a consultant that builds it for you. That's an option. You hire internal staff. That's an option. You hire a vendor that does it all for you, and you just feed them your stuff, and they compile and clean and process, and there are vendors that do that as well. So there are different options there, but ultimately the data needs to be addressed right up front. And so if I've had this conversation several times where the result of the conversation, the end of the conclusion was Mr. Customer saying, I need to get my data under control first, it sounds like. And I'm like, yeah, you kind of do. And I can help you with that, but you kind of do because you don't have access. Oh, I don't have access to syslog from my VMware environment. Well, you need it. Well, all right. So we need some layer 8 coordination going on. And then where do things live and who has the API keys and the credentials to get things? So Drew, you're right. And that's the mundane stuff. But then getting into the cleaning. So just handling things like missing rows and columns in your CSVs of flow records, things like that, all has to be taken care of. And it's not just you could dive in and start, and then it's just error handling in software development. If you're doing a POC, I wouldn't wait. I would just start and then fix the errors as they pop up. Because it is a proof of concept. You're trying to get the architecture in place and the idea in place, but it absolutely starts with the data first. Otherwise, what are you asking the LLM about?
So, Phil, let's say as a company, we've clearly defined the goal that we're trying to reach. Are we as a company likely to build this solution in-house, which the way you're describing it sounds like a monumental task many companies are not going to be well equipped to handle? Or are we more likely to buy a solution?
I think that most enterprise organizations are going to more likely buy a solution or at least buy components of this solution, like the data pipeline, or use a neocloud for utilizing somebody else's GPUs, somebody else's models. And so before I define neocloud, the reason is that it's very expensive to train a model. And so there's that component. We also talked about the resource requirement of staff, skill set, things like that. And there might be a time constraint as well.
But it's expensive both at CapEx and OpEx. That is, you got to have the hardware to do all of that, training of the model, et cetera, and a place to house that, and then an enormous amount of power consumption and other considerations, plus time to get the model. But not that your model at your company to train it might not take as long as it takes Anthropic to train the next model because they're using the entire internet as a data set. You don't have that problem, but still there's a considerable amount of upfront cost and then ongoing cost. Is that fair to say?
Yeah, that's exactly correct. But I will say that the likelihood is that you don't need to build a foundation model like Anthropic. So you don't need a trillion parameters. You can get away with far, far fewer parameters, which is the idea of the small language model, which is a domain-specific language model that is trained for what you need it to be trained on. And that's becoming a thing that people are interested in. And so you can run something like that on a handful of GPUs. And now all of a sudden it is affordable. So that is a build question. Should we be using a foundation model where it's just a model API and then we feed it data and blah, blah, blah? Or do we need something like a small language model? And if so, do we train that ourselves or do we hire a consultant? But there is a initial cost, like you said, for each of those. And then there's also the ongoing, the OpEx for sure. But there's also the security component. Sometimes you cannot use a buy because of the regulatory bodies that are governing the data that your organization uses. So you have to use something in-house. So you're downloading compiled code for Llama or Mistral, or you have some kind of very, very special arrangement with Anthropic or some other company because of that. So those are all considerations as well. A lot of the time, again, you're not buying the entire thing or building the entire thing. You're just offloading a piece. And so you have neoclouds, which if we can get to that next, basically a neocloud is a cloud provider built just for AI. And so like a CoreWeave, for example, and there are others.
So is that basically rent a GPU?
Yeah, it is. I mean, it's more than that because of the incredible complexity and infrastructure that's involved to make those GPUs work together. So I agree, it is renting their GPUs. But what you're renting is so much more. You are renting the incredible network and power and data center footprint real estate and the ability to do all that without having to update it also like any other SaaS provider. And so you can run your heavy workloads, your AI workloads in a neo cloud rather than locally, and you pay whatever the arrangement is to pay. And that that's that's an option as well. So it's
But
NeoCloud is basically a new wave of cloud providers that specialize in GPU heavy workloads, training, inferencing, and you can kind of consider them as like AI hyperscalers. That's how I like to think of them.
but I mean, I can get all that from Azure and AWS and so on. Why a NeoCloud?
Yeah, well, you kind of can't, because those clouds are not built for that kind of optimized network. They're not necessarily running on GPUs. They're not necessarily running on that kind of a backplane on their network that allows for GPUs to talk in a synchronized fashion in order to minimize job completion time and train your model within your specified amount of time. So you could do a lot of neat stuff and heavy stuff in AWS. But as many folks know that are, in very serious high performance computing environments, they end up building their own data center because it's like, I can't get the performance that I need that way. And so we have NeoClouds that they specialize in that in particular. They're not those general,
specialized. And we've recorded some podcasts with Juniper and Cisco and some others where we've talked about the nature of an AI workload for training and what the data center needs to look like, all the bandwidth, and so on. So yeah, we don't need to go off on that, but that's okay. That's the point. That's what the NeoCloud is really giving me. It's a data center optimized for training and inferencing, or is it mostly for training?
Well, both. It depends on your use case, but certainly both, because you want to inference at scale as well. So you're going to want a GPU environment. So unless you're web scale, unless your organization is web scale and you have that kind of budget, renting GPUs sort of beats building this whole thing, doesn't it? I mean, it's really just about economics and access to power and space and that kind of thing.
I've interviewed a couple of AI experts where that's what they do, AI consulting and so on. And they've suggested that the vast majority of enterprises are very likely going to be using a NeoCloud for the backend infrastructure.
Yeah, exactly. Okay. And so you have companies like CoreWeave, Lambda Labs. I can't think of any right now because, of course, we're recording. Vulture. There's a few more.
TensorWave, I think, in that space. I don't know. There's so many names. Names.
Yep.
All right, Phil. Let's bring this home. We want to map AI operations to network requirements in the context of a company that's using a NeoCloud. Then, so let's consider things like bandwidth, latency, other network requirements. And what I want to do is whatever the use case might be, if I'm a network engineer, I'm understanding I got to get data from where it is, wherever I have it, into the NeoCloud. I've got to deal with training and inferencing, get information back out of that NeoCloud. What am I thinking about? Is this just a simple exercise in WANs and bandwidth and latency? Is there more to it? Talk us through it.
So I'm going to fly through a bunch of thoughts now. And part of it is going to be the flow that you just described, but I want to make sure that we dispel some myths that you go through this process. Be ready to have these questions already answered. Like for example, if we go through this process, we're going to get 99.999% accurate answers. You're not, and if that's what you need, don't start. AI produces all the meaningful results that we couldn't get otherwise. There's no other way. Sometimes that's true. Often that's not the case, and so don't start. The more sophisticated the AI thing, the better. That's not necessarily true either. So there's some myths there before you get started, because we're going to go through a process that's very expensive. So you got to be honest. Are you doing AI for AI's sake? Do you have a strategy? We'll talk about the strategy. And then how do you identify those opportunities? So, when we're talking about operations, it starts with data. So first you have your business objectives. What do we actually want to do? In my world, if you're going to go forward with some sort of an AI initiative, it's to improve your network operations, your operational activity, IT operations, whatever it happens to be, right? So you want to improve your efficiency, get better insights. Maybe if you get more complex, you can automate some tasks with agent systems and that kind of thing. But that all starts with data. And so the first thing you have to do is, where is the data? What kind of data that we need? Who owns that data? And then how do we process that data, clean it, and prepare it to serve it to a model, right? And then start to measure those technical KPIs, which is what you just, or not measure, but determine what they should be, and which is what you just alluded to, Ethan. So if we're dealing with real-time telemetry in a real-time NOC, real-time monitoring situation, start measuring latency, not just network latency of how long it takes for packets to go from A to B, but also how long does it take this particular model to give me a response. And how long does it take for this entire data pipeline to feed that model at the end? And so being able to do like in application development, you have lineage, right, where you're looking at each step of application activity. Where is there latency in that process? And being able to identify it, make that more efficient, fix problems. And so there's a lot of moving parts here, a lot of pieces that are all very, very important. And those KPIs, though, have to be mapped to your business KPIs, right? So who cares if it's, if you're not concerned about real-time monitoring, then maybe latency isn't such a big deal, and you can get away with a model that's more accurate but has slightly higher latency. Maybe that's not an option, and so you choose a model it's pretty accurate and it's good enough, and you're good with it because it has better latency. It produces results faster, or any other step in the process. So when you're using a model API, that's something to consider. Is how much can I send them? What are the costs per token, things like that, and then how fast can I get those results? For network operations, those are really important because it's not like a giant law firm in New York City that is doing analysis on court cases and text data where it's not real time necessarily. So they're going to have different requirements. For what
so you're highlighting that depending on the use case, the nature of the pipe, the network pipes may vary.
Yeah.
Right. For network telemetry, real time matters. For other things, real time doesn't matter, and therefore how we design the network is impacted.
Yeah, and every single one of those KPIs has to be measurable. Latency, packet drops. How do you then how do you accurately measure language results? And so it starts to become difficult. There are things that we would consider a technical success, like really low latency, but it doesn't really impact the business, so it's not relevant. How do you map those together? And then also there's something called AI as a judge, which is a very, very common way to actually measure and evaluate the efficacy, the accuracy, the effectiveness of a language result, a prompt that you put in and you got a result of some sort. How do you measure that? You can have one AI measure another AI. Very, very interesting. And it's actually very effective. And that's an entire podcast. That's a whole rabbit hole of interesting things that are going on there. But you do need to consider both the model success, your business success, and the model success is a measurement of accuracy, and business success is a measurement of the model meeting your business goal. It's really that simple. So looking at
does the model's accuracy have an impact on network design?
Well, in the sense that usefulness. So maybe not accuracy, but in usefulness. Like if you need, if your data pipeline takes several milliseconds, maybe that's okay for what you're trying to do in your operations center. But if it takes several minutes, maybe it's not. And so your architecture is going to determine the overall usefulness. The answer may be accurate. Now, that being said, there is something to say with accuracy when we're talking about like traditional RAG systems and things like that. So how do you design your RAG systems so that way you are pointing at the correct databases and you're able to get contextually relevant responses in real time? So the network plays a role in the sense that the GPUs need to talk to each other. But again, Ethan, we're not necessarily building that GPU network.
Right, because I've offloaded that to the NeoCloud. That's their problem. I'm assuming that they're going to deal with that for me. Mostly I'm thinking about getting data into the NeoCloud's environments, that as I'm renting their GPUs, so to speak, in their infrastructure, it's getting there in a timely fashion and so on.
Oh, yeah. And then you start to consider things like that are akin to like AWS's Direct Connect and things like that, and your high bandwidth links and redundant links. Absolutely. So there is that, similar to what we're used to with our SaaS providers and cloud providers. But that's not always necessary either, because often you're sending your data kind of like you do like a backup job, and you send all your data there, and now you have it there to analyze and to do something with. And so your prompt is very minimal traffic. That being said, that's not the case necessarily for network operations where we're dealing with real-time telemetry. And so sometimes we have to think through that architecture, because we are talking about, I want to know what just happened and why. And that's different.
And thinking about the NeoCloud model, I was thinking about it as this is sort of a short-term relationship. I'm sending some data in, running on some GPUs for some time, and getting a package back, and then I'm done with it. But should I be thinking about it more like infrastructure as a service, where I may have a years-long engagement with this organization?
Yeah, I mean, it could be both, but I would say the latter for a lot of organizations moving forward. We're going to see this flesh out, by the way, over time.
Mhm.
But as folks adopt an AI initiative and they go through the question of build versus buy, as they go through the process of developing their strategy and mapping KPIs and all that stuff, they'll very often come to the conclusion, I predict, that they are going to put this in somebody else's GPU data center, and the NeoCloud is the answer, in which case it's part of their workflow, Drew. It's part of their operations. And
Mhm.
so over time, you're going to see that. And, I do wonder, this is not a technical prediction, but I wonder if some of these NeoClouds will consolidate and we'll start to see consolidation of resources, because
And
now, even
acquisitions
now,
for sure. Yeah.
folks can't build a big enough data center in a particular geographic location because there just isn't more real estate, and they can't build anymore because of permits and whatever else. And so we're seeing a data center, which is actually like 4 data centers in a city, right? And they're connected with very, very high bandwidth links. And so we're seeing that kind of architecture. So I wonder if we're going to see consolidation of neoclouds, and people rely on them, similar as to how we shifted to public cloud like AWS and Azure some years ago.
I think there's
Okay.
too many neoclouds out there, just from what I'm reading. They can't all survive, so there'll be some consolidation in the form of the winners are going to need more bandwidth, or they're going to need more compute power, let's say,
Yeah.
and they're going to acquire someone else that built and didn't get the customer base. Things like
Yeah.
that. That's just what always happens. That's going to happen. Uh, okay, so we've got the kind of the traditional I'm talking to cloud network design concerns. I have to pay attention, like always, to what the nature of the workload is that's going across those wires, and understand what the characteristics are via measurable KPIs of, in this case, an AI application is. And then with that information, I understand what the network needs to look like. So it doesn't sound radically different, Phil, from anything we've done before.
Nope.
In this case, when I'm renting a NeoCloud, if I'm building my own AI data center to do training and inferencing, we're having a very different conversation. But we're leaning into what we think the most typical enterprise scenario is, which is your company's gonna rent those resources, and you just need to get data from where you have it to where it goes. And as you said, it may or may not be a big deal how much bandwidth you've got, because if it's not real time, you're just going to send a big chunk up there, and you could even do that offline, all depending on the scenario.
Yeah.
So we're not, I don't feel like we're on uncharted territory, but where it may be a bit new for the average network engineer is understanding with AI what is the nature of the workload and a transaction, if you will. We should know. I was going to say we all know, but that's not necessarily true. But we should know like what an HTTP transaction looks like, and how to build a network that's going to give you a successful HTTP transaction. In this case, it's an AI transaction, which looks somewhat different and has different latencies and so on. But with that knowledge, we can then go forth and spec out whatever the network needs to look like to support that, with proper redundancy, bandwidth, latency characteristics, loss, jitter. Right? It doesn't feel crazy different. Am I right?
It isn't, but I think it's just something that's not being discussed right now. It's certainly concepts of software development and just technical architecture that we've been discussing for years. It's part of what we do. But for some reason, like everybody forgot about that when we started talking about AI. And I think we really need to bang this drum and say, all right, everybody, as we're now kind of experimenting with even moving forward, I'm already seeing blog posts that are like, AI agents are over. What's the next step? I'm like, they're not over. What are you talking about? We're still trying to figure this stuff out. It really is about identifying those initiatives for a typical enterprise, and then building out the architecture, whether you're renting GPUs or you're just using a foundation model and a model API like GPT or Claude, and those are completely fine to do as well. But again, there's a component of design and infrastructure and security and data management, all that stuff, data loss protection, all that stuff has to be involved there. Now, that's for what I would consider a typical enterprise. 80-90% of enterprises, there are those exceptions, and I have some of those exceptions as customers where they're building AI data centers of their own for various reasons, usually regulatory concerns, privacy, things like that. But also, Ethan, to address your point, this is not for the AI data center itself. That is a very different conversation, and that would be a really interesting podcast to get into. Talk about the tiers of networking that exist, the types of networking, the requirements, what job completion time is all about, that sort of thing. There's quite a bit there.
Which you've
some
written
really
about. I
interesting
know,
technologies.
yeah, you blogged
Yeah.
about things like JCT and so on. So yeah,
Yeah.
those are
Yeah.
all very interesting things. Well, Phil, I think we got to bring this pod to a close. This has been good framing of the problem and understanding what's really going on under the hood, and having insights into what the C-suite might not know that they're asking for when they're asking for this. I think a lot of the I've been in a lot of conference rooms where a project's kicking up and someone says, "Oh, I think we ought to do this." It's like, "Oh no, that means these 6 other things, and I don't think that's actually what we want to do." Oh, and then
Right.
the course of the conversation changes a lot, and I feel like walking into a room armed with the knowledge you've shared with us today might actually drive a conversation like that. Oh, you think we need to do AI and train our own LLM? Well, why? What problem are you trying to solve? I just want a chatbot.
Yeah.
Well,
Yeah.
okay. I mean, maybe we don't need to go down this road, because here's what you're actually wanting to get into.
Hmm.
Phil, thank you for sharing today. Your knowledge is, I could tell as you started going off in different topics, like, oh man, Phil's a deep well here. We got to tap into some of this knowledge in some other
It's fun
shows.
stuff. It's fun stuff for sure.
If people want to follow you, Phil, how do they find you?
Sure. Well, you can search my name, Philip Gervasi, on LinkedIn, where I'm most active. I still do use Twitter from time to time, so you can find me there at network_Phil. On Blue Sky as well. Network Phil. There's no underscore there, thankfully. And my blog, networkphil.com. I also write for Solutional and for Kentik, so I'm all over the internet, and it's a lot of fun. But thank you so much, guys, for having me on today.
And thanks for being here, Phil. Much appreciated. And thanks to you for listening today. I know there was a bunch of setup and context to get to the network architecture part of the conversation that came at the end. But the point of the setup was to communicate enough about AI operations that you can read between the lines of what you're being asked to build, so that you can infer the network requirements from there. As so often we are asked to do, as the network is a second thought, way too often. Anyway, to do that, to be able to infer those requirements, you need to know what's happening with training, inferencing, and other AI operations. So you got that starting point of what the network might need to look like. We got there though. So please give Phil a follow on LinkedIn. And once you've done that, do all the things for me and Drew: like, share, subscribe, leave a review or a comment wherever you listen to podcasts, including Spotify and YouTube. If you didn't know, we're on YouTube. A lot of people we're finding are actually beginning to consume podcasts on YouTube. That's like the one player. And if you're that person, all the pods are there. Just go to the Packet Pushers channel, and all of our pods are published up there now as well. If you have a topic request or a follow-up about this show, send them to us at packetpushers.net/follow-up. And hey, we got a merch store where you can buy shirts and mugs and hats and so on. I know you were going to get that Packet Pushers tattoo, but you don't have to do that anymore, because a shirt is way less permanent, and you can throw it out later when you decide you don't like us anymore. So find the store, our newsletters, blogs, videos, and of course, so many podcast series, all at packetpushers.net. Last but not least, remember that too much networking would never be enough.